So today we are going to start KTG and thermodynamics. That is also one of the most important part. So KTG and thermodynamics I will try to cover in either one lecture or two lectures maximum. Correct. So let's start. Kinetic theory of gases, KTG plus thermodynamics. So see, first of all, like ideal gas, ideal gas. So what we assume that all the real gases at high temperature should be very high, and low pressure. They behave as ideal gas. Means ideal gas is basically a hypothetical concept. But if real gas, normal gas, if they are at very high temperature and at very low pressure, we can treat them like ideal gas. So all the real gases at high temperature and low pressure can be treated like ideal gas. Okay. Now see, all these ideal gas follows two relation. First, PV equals to nRT. P is pressure of the gas, V is the volume of the gas, N is number of moles, R is gas constant, T is temperature. PV equals to nRT. This you must be knowing. What is the value of R? 8.314 in SI unit, R value. And second, they also follow this, PV to the power X equals to constant. Correct? Where X is index. We will see what is index and all. But always remember, all ideal gas follow these two equations, PV equals to nRT and PV to the power X equals to constant, where X is index. Correct? Okay. Now we have some relations that you need to remember. P by rho equals to RT by M equals to KT by small m. Very important relation. P by rho. I am not deriving. This is pressure of the gas divided by density of the gas. R you know, D is temperature, M is molar mass. M I am writing, M is molar mass of gas. K is Boltzmann constant. Boltzmann constant. 1.38 into 10 power minus 23. This is the value of K. T is temperature. M is mass of one molecule of gas. Mass of one molecule. So this relation is very important. You need to remember. P by rho equals to RT by M equals to KT by M. In the question, sometimes you will see that these values are given. They will ask molar mass. Correct? All the values will be given and they will ask the molar mass like that. Similarly, they can give this, they can give this, they can give this, they can give pressure, they will ask what is the density. Correct? So this formula you need to remember. Fine. Then we have some laws, like see, Boyle's law. Okay. You remember the word bat. Why I am telling? B for Boyle's law and T for temperature. What it says, at constant temperature, if the temperature is constant, correct? We have three parameters: pressure, volume, temperature. We will be discussing the relation between them: pressure, volume, temperature. So if temperature is constant, what they say, the pressure of the gas is inversely proportional to volume. Pressure of the gas is inversely proportional to volume. Or we can write P1 by P2 equals to V2 by V1. So again I am saying Boyle's law. You remember the word bat. B for Boyle's law, T for means temperature will be constant in this process. At constant temperature, pressure is inversely proportional to volume. So P1 by P2 equals to V2 by V1. If I cross multiply, what we can write? P1 V1 equals to P2 V2. Means we are going from stage 1 to stage 2. For example, see. We have applied some pressure. This is stage 1. We have applied some pressure. The pressure is P1. Correct. Temperature is some T. Volume of the gas is what? V1. Correct. What they are saying, that if we increase the pressure, inversely proportional, means if we increase the pressure, volume will decrease. And you know, if we increase the pressure, what will happen? Like syringe, volume will decrease. If we increase the pressure, what will happen? This piston will go down and volume of the gas will decrease. Means when we are going from stage 1 to stage 2, pressure is increasing but volume is decreasing. Means P2 is greater than P1 but V2 is less than V1. That I am writing P1 V1 equals to P2 V2. In stage 1 there must be some pressure, some volume. In stage 2 there must be pressure, some volume. The product will always be constant. Or we can write PV equals to constant. PV equals to constant. Achha, if I see this equation, compare with PV to the power x equals to constant. I told you all the graphs follow this equation. What is the value of x? 1. Value of x, what we can write? See, PV to the power constant. PV equals to constant and PV to the power x equals to constant. So what should be x? Here what is there? 1. Means here index value, this x value is what? 1. Index value for isothermal process is 1. Always remember, constant temperature process we call by a name, that is isothermal process. Isothermal process. Isothermal process. Next, Charles law. You remember the word cap? C for Charles law, P for pressure. Means what it says, that at constant pressure, if the pressure is constant, what are the other two parameters? Volume and temperature. Volume of the gas is directly proportional to temperature. If you increase the temperature, volume will also increase. If you increase the volume, temperature will increase. Means V1 by V2 equals to T1 by T2. If we increase the temperature, volume will increase. Temperature. Charles law, directly proportional. If you heat something, volume decreases. Suppose there is a gas, ideal gas, any gas. If you heat, what will happen? Molecules will go apart. You know, na? Suppose molecules are located right now, here and there, some molecules are there. If you heat, they will get energetic. They will move away from each other. Their volume will increase now. So always remember, if you increase the temperature, volume increases at constant pressure. The pressure is constant. So V1 by V2 equals to T1 by T2. This constant pressure process is also called isobaric process. Isobaric process. Correct? So you think one thing. Suppose PV to the power x equals to constant. This I told. All gas follow this equation. If x value you put 0, what we will get? P V to the power 0. V to the power 0 means 1. So pressure equals to constant, means isobaric process. Means in isobaric process, the index value has to be 0. Remember, isothermal process index value 1. Isobaric process index value 0. So these things you should remember. Next we have Gay-Lussac's law. You can remember the word guava. G for Gay-Lussac's law, V for volume. What it says? At constant volume, mean in Gay-Lussac's law, volume will be constant. If the volume is constant, pressure is directly proportional to temperature. Means if you increase the pressure, the temperature will increase. Means we can write P1 by P2 equals to T1 by T2. Achha, this constant volume process is also called isochoric process. Isochoric process. And remember, the index value for this is infinity. Index value, if someone asks, it is infinity. Correct? So these are the some process, and we have to remember the relations. They can ask anytime. Okay, anytime they can ask. these questions. Also, we should remember other process also, like adiabatic process. Adiabatic process, for example, what is an adiabatic process? A process in which heat interaction is zero. Means no heat can enter to the system, no heat can exit out of the system, or net heat, you say, net heat interaction is zero. Means heat is zero. Adiabatic process. Acha, here what we write? Here X we write gamma. X we write gamma. Gamma is called adiabatic index. Okay. Yeah, this index value is equals to gamma. This is adiabatic index. So we can write, we know that PV to the power X equals to constant. In adiabatic process, we can always write PV to the power P1 V1 to the power gamma, because X is nothing but gamma, equals to P2 V2 to the power gamma. So this value is constant. Okay. See, suppose we have a container and we have some gas inside the container. So there are millions of gases. So gases are moving randomly. Some gas moving here, some gas moving this direction, some gas moving this direction with different speed. Correct? Like one gas moving with 2 meters per second, one gas moving with 4 meters per second, one gas moving with 1 meter per second, like this. Example I am taking. All the gases are moving with different speed. So we define different speed of the molecules of gas. Different speed. First of all, if they ask what is the average velocity? Average velocity of gas. So see, due to the random motion, like some are going there, some are going there, some are going, like some are moving there, 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 some are moving there. Due to all this random motion, the net, they can cancel each other, na? So the average velocity, if someone asks, so average velocity is always 0. Correct? For example, like suppose there are two molecules. One molecule is moving in this direction and one molecule is moving in this direction. Its speed is 2 meters per second. Its speed is also 2 meters per second. So average, if I write V average, so its velocity is 2 I cap, this direction I cap, but this direction, this is minus I cap now. So this will be minus 2 I cap divided by 2. So this will be what? 0. So average velocity will be 0. But if they ask what is the average speed, that won't be 0 now. Average speed, it is a scalar quantity. Suppose you are having some speed 30, 40. So average 30 plus 40 by 2. We can calculate like this. So average speed won't be 0. Remember this. Average speed is not 0. Now, 3 kinds of velocity, or 3 kinds of speed they mention. First, RMS speed, VRMS, root mean square speed, root mean square velocity. Second, average speed. Third, I will tell you what are these things. Most probable speed. Okay. For example, suppose there are 3 molecules. The speed of molecule 1 is 1 meter per second. The speed of molecule 2 is 2 meter per second. Speed of molecule 3 is 3 meter per second. Correct. So if someone asks what is the average, so 3 plus 2, 5 plus 1, 6 divided by 3, 2 meter per second. If someone asks what is the average speed, so 3 plus 2, 5 plus 1, 6, 6 divided by 3, that is 2 meter per second. This will be the average speed. So average, you know, what is the average speed? Next is RMS speed. RMS speed, root mean square. It is written as root mean square, but we do just opposite. First we do square, then we find mean, then we do the root. See how to do. First we will do square. So 1 square will be 1, 2 square will be 4, 3 square will be 9. So first we did the square, then we will find the mean, means average. So how we find average of these 3 numbers? 1 plus 4 plus 9 divided by 3. So 9 4 is 13 plus 1, 14 by 3. So root square we calculated, mean we have done. Then we have to do root. We have to find the root. So this is the RMS velocity. Understood? This is the RMS velocity. Acha, one more thing. This RMS velocity is also the representative of the velocity. Like in a class, there are a lot of students. We make one monitor to represent that class. Similarly, lot of there are n number of molecules in a container. They are having different speed. So RMS speed means that is a representative velocity of that container. That represents, okay, the RMS velocity is here. The effective speed of the particle here, it is something, whatever. There is formula to calculate this. RMS speed formula. So always remember, RMS speed of gas formula is under root 3 times P by rho. This average speed is, this is RMS speed. This average speed is little less than this, little less than 3. How much? 8 by pi. 8 by pi, if you solve, it is little less than 3. P by rho. And its most probable speed is less than this, 2 P by rho. This formula you have to remember. Correct. Acha, one thing I told you, that P by rho equals to RT by M. I started the class with this, P by rho equals to RT by M equals to KT by M. So here we can write 8 by pi RT by M. Here we can write 2 RT by M. Or we can write also like this, P by rho is RT by M equals to KT by M. Now what inference we can make? That any kind of speed, whether it is RMS, average, most probable, any kind of speed, you see the formula, you see from here. All velocity, you can see, is directly proportional to root of the temperature. Here also root of the temperature, this speed is also directly proportional to root of the temperature, this speed is also directly proportional to root of the temperature. So any kind of speed of gas molecule, always remember, is directly proportional to root of the temperature. So they ask question from here. Okay. Like for example, they will give that at 25 degrees Celsius, speed of the gas is 40 meter per second, for example. So they are asking at 125 degrees Celsius, what will the velocity of the gas? So how to calculate? So we can write V1 by V2 equals to root T1 by T2. V1, how much given velocity of gas? 40 divided by V2, they are asking V2 equals to root T1. What was the temperature? 25. But don't do this mistake that you have written 25. Convert in Kelvin. Convert in Kelvin. So 273 plus 25, 298 divided by its temperature 125, convert in Kelvin, 398. From here you can find V2. Correct. Achha, what is most probable velocity? Most probable velocity is that velocity which maximum number of gas molecules attain. Understood? Means suppose I have 100 molecules of gas in a container, 100 molecules. Suppose 90 molecules out of 100, 90 molecules are moving with same speed, that is 1 meter per second. And other 10 are moving with different speed. Means some is moving with 4, some is moving with 6, 2 are moving with 8. But maximum molecules are moving with what speed? 1 meter per second. So this 1 meter per second is called most probable speed. Most probable means if you take out randomly any molecule from the container, most probably its speed will be 1 meter per second, because maximum molecules are having that speed. So most probable speed is that speed that the maximum number of molecules in that container have. Correct? So that is most probable speed. Okay. Then we have Maxwell distribution curve. What is this? See, this is number of molecules, and here they have plotted different speed. Graph is like this. Suppose graph is like this. You have to tell, like if I say this speed, what should be this speed? See, this speed is attained by maximum number of molecules. This here it is number of molecules. See, so maximum number of molecules are attaining this speed. So this will be what? Most probable. This will be what? Most probable. VMP, most probable speed. Why? Most probable speed is that speed which maximum number of molecules possess. So maximum number of molecules possess this speed. Acha. See here, this is 3, this is less than 3, this is further less than 3. Means always remember, VRMS is greater than V average, which is greater than most probable. You can remember like the word Ram. Means R for RMS, VRMS is greater than V average, average speed, greater than V most probable. Correct? RAM, RAM. So V most probable is here. What I said, average speed is little more than most probable. So this will be V average. And RMS speed is maximum. So this speed will be RMS. V RMS. Correct. Now this graph is for suppose temperature, any temperature T1. Now what happens if we increase the temperature? If we increase the temperature, just now we have seen, if we increase the temperature, this temperature, see, root T, I told now that velocity of gas is directly proportional to root T. Means if we increase the temperature, the speed of the gas should also increase. The speed of the gas should also increase. If we increase the temperature, the speed of the gas molecule should also increase. So if we increase the temperature, the graph will be like this. See, this temperature T2, I am saying it is greater than T1. So if it is greater than, so here all the speeds will be more, because if you increase the temperature, speed will be more. Means it's most probable, this is the most probable speed, will be more. See here for this T1, most probable speed was here. For this T2, because T2 is more, so speed will also be more. So V most probable will be here. Similarly, V average for this will be here. Similarly, V RMS will be here. So this is the maximal distribution, Maxwell's distribution curve. Always remember, if you increase the temperature, the graph shifts right direction. See, it has shifted right. Graph shifts right. However, the peak value decreases. The peak value here it was high, here it is low. Peak value decreases. See, next is degree of freedom. F, degree of freedom. What is degree of freedom? Number of independent ways in which a molecule can have motion. Again listen, number of independent ways in which a molecule can have motion. For example, what is the meaning of the sentence? You tell me, if I put one nail over here and put one nail over here and tie one rope, and if I ask one chima, if I place here, so in which direction we have restricted it to go? One direction. So in how many ways it can have its motion? In only one way. Understood? But if I place this chima here on the wall, it can have its motion in x direction as well as y direction. Understood? First case, this chima was forced to move along this rope, along one direction, along x direction. Suppose this is x direction. But in this case, when I put the chima on the wall, it can move in x direction as well as y direction. So degree of freedom 2. In two ways it can move. If I put one butterfly here, it can move in x direction, it can move in y direction, it can go in z direction also. So number of independent ways in which it can move, 3 ways. Correct? So degree of freedom 3. We can think like this. So similarly, a gas molecule, how it can move, we have degree of freedom. We are not going much depth, but you just remember, like for monoatomic, we have different types of gas. Monoatomic means helium, argon. So monoatomic. Then we have diatomic, oxygen and all. Then we have triatomic, but shape is linear. Triatomic, but whose shape is linear. Tell me any molecule whose shape is linear. Tell me any molecule whose shape is linear. CO2. Okay, correct. And then we have last case, triatomic, non-linear. Any molecule whose shape is non-linear? H2O, non-linear. So we have this different categories. Okay, we have different categories like this. They ask what is the degree of freedom. See, one thing they ask, translational degree of freedom. Translational degree of freedom means in how many ways it can have translation motion, linear kind of motion. Then we have rotational degree of freedom. In how many ways it can rotate, rotational degree of freedom. And then they ask total degree of freedom. This is very important. Total degree of freedom. Total degree of freedom F. We represent by the letter F. For remember this, for monoatomic this is 3 in 3 ways. For diatomic also this is 3. This also 3. This also 3. And one more thing you remember, that this diatomic and this triatomic linear behaves same. It behaves same. Whatever you are getting for this, you will get the same for this. Just you remember. These two behave same. Acha, coming to the rotational degree of freedom. Rotational degree of freedom. In how many ways monoatomic can rotate? Tell me. In how many ways this can rotate? No idea? These things you didn't study. These are the most common things. How you gave that NEET exam this time? First time you gave NEET exam? See, translation degree of freedom, for all 4 cases we have 3, 3, 3, 3. Rotational degree of freedom, for here this is 0. Correct? For diatomic this is 2. And I told you this and this will behave same. So here also 2. For triatomic non-linear this is 3. Correct? Total degree of freedom 3 plus 0, 3. 3 plus 2, 5. 3 plus 2, 5. 3 plus 3, 6. 6 degree of freedom for triatomic non-linear molecule. These are very important things. Very, very important. I wonder how you people don't know. So you learn these values. The translation degree of freedom 3, 3, 3 for all. rotational 0, 2, 2, 3. Total degree of freedom, this value you should remember at any cost. Total degree of freedom 3, this is 5, here also 5, and here it is 6. Total degree of freedom. Correct? 3, 5, 5, 6. Next, law of equipartition of energy. Law of, we have lot of things are there. KTG plus thermo, see. This 2 chapters I am clubbing in one. Correct? I am trying to club in one. So it may be like 2 sorts or 1.5 sort. Correct? So law of equipartition of energy. What is law of equipartition of energy? What it says that energy of one molecule associated with 1 degree of freedom means if there is one molecule, its degree of freedom, suppose it is 1, then its energy will be half kT. Then its energy will be half kT. Correct? This is law of equipartition of energy. What it says in other sentence, one more thing, that total energy associated with the molecule gets equally divided for its each degree of freedom. For example, if total energy is 60 joule, just example I am taking, and this molecule is monoatomic molecule. Monoatomic, this is gas. This gas is monoatomic gas. So monoatomic means degree of freedom will be how much? 3. Total degree of freedom is how much? 3. So each degree of freedom will have 20, 20, 20. So 3 degree of freedom has 60 joule, means energy associated with 1 degree of freedom will be 60 divided by 3, 60 by 3, that is 20 joule. So the energy associated with molecule is divided equally for each degree of freedom, means each degree of freedom will have same energy. Okay, means in exam this kind of questions they don't ask, but what they ask, see, little bit of derivation is required. Like one molecule 1 degree of freedom, energy is how much? Half kT. Half kT. So if we have one molecule, this is from law of equipartition of energy. This is from law that if there is one molecule, it has 1 degree of freedom, its energy will be half kT. So if there is one molecule and if it has f degree of freedom, f, so its energy will be you multiply F. So F by 2 kT. If we have 1 mole molecules, then what will be the energy? You multiply with, this is 1 molecule, you multiply with Avogadro's number, Na, FRT by 2. If we have n moles, that in a container, generally we talk about moles, na? That this container is having 2 moles of gas, 4 moles of gas. If we have n moles, then what we will write? N into Na, FR T by 2. Correct? This is K, na? K. This is K. K. Always remember, this Na into K, this is Avogadro's number, multiplied by Boltzmann constant, is R. R means gas constant, 8.314. This Na multiplied by K is equals to R. So Na multiplied by K equals to, we can write R. Means the energy becomes M F. See, here we have N, I have written N. Here we have F, I have written F. Na into K will be R. So R T by 2. This is important. What is important? I am saying N moles of molecule, N moles of a gas having F degree of freedom has energy equal to NFRT by 2. Means if someone asks that if we have N moles of a gas, what is the potential energy or what is the internal energy? This we call internal energy also. Internal energy. What is internal energy? The energy of all the molecules. Like in a container, there will be a lot of molecules. Now, every molecule is moving, they are having some energy. So, energy of all the molecules is called the internal energy. So, internal energy formula, you remember like this, nafrat. There is a word in Hindi, nafrat, pyar, mohabbat, nafrat. So, nafrat by 2. Acha, this Fr by 2, na? Fr by 2. This term is also called CV. What is CV? You must have heard. Specific heat at constant volume. Cp, Cv. Cp minus Cv equals to R. So this is CV. So we can write U equals to NCV T. We can write like this also. What is CV? Specific heat at constant volume. Okay. So these two formulas are very important. U equals to nafrat by 2 or NCV, then nafrat by 2 or NCV T. Correct? Acha, if we are changing the temperature, if we change the temperature, U value will also change. So if they ask what is the change in internal energy, if we change the temperature, what we will write? Nafrat NFR delta T, how much we are changing? By 2. Or we can write like this also from here, NCV delta T. Correct? So these formulas are very important, Nafrat by 2 or NCV delta T. Always remember delta U formula, NFR delta T by 2, NCV delta T. Correct? Now see, next we have zeroth law. Now before zeroth law, okay, zeroth law of thermodynamics. What is zeroth law? It says that if the body A is in thermal equilibrium with B, thermal equilibrium, and the body B is in thermal equilibrium with body C, then body A will be in thermal equilibrium with body C. This symbol I am representing for thermal equilibrium. Thermal equilibrium means, what is thermal equilibrium? Like suppose there is a body, it has temperature 40 degrees Celsius. Correct? I connect with this body with a rod, and there is another body whose temperature is 20 degrees Celsius, and this is a rod. What will happen? Its temperature will change. Heat will flow from high temperature to low temperature. So heat will flow like this. Now what will happen? If heat flows, this will cool down, and heat goes to this, so this will heat up. So what will happen after some time? Suppose this temperature decreases to 30 degrees Celsius, and this temperature also becomes 30 degrees Celsius. Now, will there be any change in its temperature now? No, there will be no change in temperature. Why? Its temperature is also 30. Its temperature is also 30. So heat will not flow. So this is the stage of thermal equilibrium. When the properties of the body does not change, or the temperature of the body does not change, this is called thermal equilibrium. This object is now in thermal equilibrium. This object is also in thermal equilibrium. Now no heat will flow. But here they are not in. This is not in thermal equilibrium. Here this is not in thermal equilibrium. Here heat is flowing. So temperature is changing. But here temperature remains constant. Not in thermal equilibrium. So thermal equilibrium means temperature will be constant. So what is zeroth law? That what it is saying, if body A is in thermal equilibrium with B, means suppose this is body A, this is body A, this is body B. This body A is in thermal equilibrium with body B. Means suppose this temperature is 40. It is in thermal equilibrium with B. Means this temperature will also be what? 40. That's why. Otherwise, if the temperature is different, they won't be in thermal equilibrium, because heat will flow now and their temperature will change. So right now they are in thermal equilibrium. So if A is in thermal equilibrium with B, remember this is conductive wall. Conductive wall means heat can conduct, but now it will not conduct because both the temperature are same. And body B is in thermal equilibrium with C. Body B, suppose I draw like this. Body B is in thermal equilibrium with C. Means here also temperature will be 40 degree because they are in thermal equilibrium. If it is not 40, then heat will flow now. So temperature will change. Means here also temperature will be 40 degree. So if A is thermal equilibrium with B and B is in thermal equilibrium with C, then A is in thermal equilibrium with C. See, A and C are also in thermal equilibrium. If I join any rod like this, will heat flow? No heat will flow. Why? Because here also temperature 40, here also temperature 40. So no heat will flow. Means A and C are also in thermal equilibrium. So this is zeroth law. One more thing that you need to remember, let's see. There is one property of temperature. We have different scales, temperature scales. That also you should remember. Temperature scales. Temperature scales. Like see, we have temperature in degree in Kelvin equals to 273.15 plus temperature in degree Celsius. This is a relation that you need to remember. Correct? Means suppose someone gave you that 100 degrees Celsius. Correct? You have to convert in Kelvin. I can write like this. You can write like this. Temperature in Kelvin, temperature in degree Celsius, temperature in Kelvin. So suppose someone give you this example I am taking, that 100 degrees Celsius is equals to what Kelvin? How much Kelvin? So see, if you want to find the temperature in Kelvin, so temperature in Kelvin is equals to 273.15 plus temperature in degree Celsius. How much? 100. Temperature in degree Celsius is how much? 100. So 273 plus 100, that is 373.15. So 373.15 Kelvin. Second relation which is important. Temperature in Fahrenheit equals to 9 by 5 C plus 32. Fahrenheit, where you have seen Fahrenheit? In thermometer. When we have fever, that temperature we get to 9900, that is in Fahrenheit. So temperature in Fahrenheit equals to 9 by 5 C plus 32. Like they can give, if temperature in Celsius is 100, what is the temperature in Fahrenheit? Correct? Then you can calculate in Celsius, you will get in temperature in Fahrenheit. Here one important question is there, that if you put C value minus 40, F value will also you will get, this is the unique value. At minus 40, F value will also, you will also get minus 40. If you put minus 40, you will check and see that F value will also come minus 40. See, all the scales follow one rule. Again, I am highlighting. They can ask this time. All the scales follow one rule. X or T minus Ti divided by Ts minus Ti equals to constant. Now what is this? Very important. Ti is ice point temperature. Ice point, the temperature at which ice is formed. And Ts is steam point temperature, the temperature at which we get steam. So Ti is ice point temperature. Ice point temperature. Ts is steam point temperature. Now, what kind of question they can ask? See, they will say that we have a Celsius scale. Celsius scale. Again, I am saying, what is this formula? All the scales follow this rule. All scales follow this rule. So, they have given, there is a Celsius scale. And temperature in the Celsius scale is, suppose 40 degrees Celsius. Correct? There is another scale. There is one new scale or some different scale. Like we have a different kind of scale, Kelvin scale, Fahrenheit scale. There is some new scale where ice point temperature is 200 degree and steam point temperature is 400 degree. Means in that new scale, water, like ice is formed at 200 degree and steam is formed at 400 degree. They are asking, when the temperature in the Celsius scale is 40 degree, what is the temperature in this scale? When that, again I am saying, when the temperature in the Celsius is suppose 40 degree, what is the temperature in this scale? We will use this formula. See, very easy only. How to use? So we will write this formula for Celsius scale is equals to, we will write this formula for new scale. So see, for Celsius scale, T they have given 40 degree minus ice point. What is the ice point for Celsius scale? 0 degree. We will write 0. Divided by steam point. What is the steam point for Celsius? 100 degree. At 100 degree Celsius steam forms. Minus ice, Ti, ice point temperature 0, equals to. This formula is, I told you, is valid for all the scales. So it is valid for the new scale also. So for 40 degree, here what will be the temperature? That we have to calculate. We don't know. But if the temperature in the Celsius is 40, what is the temperature in the new scale? That we don't know. Minus ice point temperature 200, steam point temperature 400. This formula you have to apply. Minus again ice point temperature, that is 200. So you can solve this and you will get the answer. Correct? Then we have first law of thermodynamics. First law of thermodynamics. What is first law of thermodynamics? For example, there is a beaker. You think like this. There is a milk. It is applicable for gas, but so that you understand, I am taking one example. There is a milk and there is a container. Means container means cover, plate. Correct? This is the container. Here we have milk. This is the milk. What we are doing? We are supplying some heat. We are heating this milk. We are supplying some heat. The energy, heat energy we are supplying, I am calling this dQ. Correct? Now what happens? You will see now that suppose you are boiling the milk. After some times, lot of steam will come and the container, that cover, lid, this cover, suppose this is a plate will vibrate like this because steam is striking that. Have you boiled milk? And there is a container, there is a milk, and suppose you have kept something so that it does not come out. Now as the steam is pushing, striking that surface, the container will vibrate. And if it is too much, this will fall. Means this lid or this cover will move from here to here. It will jump due to its pressure. Correct? So what we can see, this gas molecules, whenever they acquire some heat, they become energetic and they push this lid from here to here. Means they are applying some force. They are applying some force and there is displacement of this cover, lid, suppose dx. Means they are doing some work. These gas molecules, they are doing some work. Acha, when you are heating this gas, the temperature of the gas is also increasing. The temperature of the gas is also increasing. Suppose U was the U initial. What I can write? NFR T initial by 2. This is the formula for U. But since you are increasing the temperature, you are providing heat, so temperature will increase now. So U final will be NFR T final, temperature final, because it will get heated, temperature will increase. This. Achha, which is more, this or this? This is more, because now temperature is high. Means what we can see, delta U we are getting. Delta U means final internal energy minus initial internal energy. So what is having, suppose you are providing 100 joule of heat, there will be some change in internal energy of this gas. Suppose this is 80 or 20 joule. Out of 100, this 20 joule is used in changing the temperature of the gas. And the rest energy is always conserved. And the rest energy, the gas do the work. There is work done by the gas. How? Because it is applying force and displacement of lid is there. Force into displacement, work, means there is some work done by the gas. In this example, if someone say how much work, so you have provided 100, out of 100, 20 joule is utilized in changing the internal energy and work done by the gas will be so 80 joule. So 80 plus 20, 100. Means you consumed 100, 20 you changed yourself and 80 you did the work. So how they define first law of thermodynamics? First law for any process, that whatever heat energy you give will be equals to change in internal energy plus work done. This is the first law of thermodynamics. Correct? Acha, work done. Someone asked, what is work done? Work done, can I write this work done? What was the work done by the gas? How much gas applied the pressure? Means force multiplied by displacement. Force on the plate, that lid cover, force on this cover multiplied by displacement. What is force? Can I write force equals to pressure applied by the gas multiplied by area? Because we know that pressure is nothing but force by area. So force applied by the gas, we can write pressure into area, that is pressure applied by the gas multiplied by area of the container. multiplied by dx, displacement of the, now this A into dx, area into length, this can we write this volume dV, how much volume changed, initial volume was this, final volume of the gas is this, so what is the change in volume, this is the dV. So A dx, area into length, is nothing but P dV. So always remember that work done formula is integrate both sides, integration of P dV. This is also important. So you can write first law like dq equals to du plus dw, and dw you can write P dV. This is the work done. This is also the first law of thermodynamics. Correct? So always remember this thing, that work done formula, very important, work done formula is nothing but integration of P means pressure of the gas, dV means change in volume. Acha, if we have PV graph, pressure versus volume graph, and there is any graph like this, so what is the area under the graph? This area under the graph. So area under the graph is, we know area, general formula is integration of y dx. This is the general formula, basic mathematics, you see the lecture. So here in place of y axis we have pressure, in place of x axis we have volume. So P dV, and integration of P dV is nothing but work done. Means we can write work done equals to area under PV graph. This is very important. Work done equals to area under. If someone asks what is the work done by the gas, so area under the PV graph. This PV graph they can ask work done. So it will be the area under PV graph will give work done. Okay. So for today, I will keep it till here only. Tomorrow we are going to complete this chapter. Okay. So revise all the formulas, all the important things I have told. Just you have to see the formulas, memorize the formulas and solve questions. Okay. So tomorrow we are going to complete this thermodynamics. Okay. Thank you.